So let's go to general Q&A and other questions for Wolf.
Yeah, I actually had a question about the CBOR. Have you looked at the Caesar in the carry suite?
I have not. I mean, if you want to put a link in the chat, I'd be happy to check that out. What would you say is its difference or primary point of differentiation?
It's a round-robin composable format between readable and binary text format. So, sorry, readable text
is it
format.
a competitor for CBOR? Is it something that basically is?
Sam Smith has designed it with his team because he couldn't use CBOR in the carry environment. So you might want to have a look at it and maybe disclose it right away.
Yeah, Christopher has mentioned it's KERI, right?
Yes.
Yeah. Okay. So I have looked a little bit, but not enough to really make an informed comparison.
I think we address a lot of the problems that are they encountered with the envelopes, because CBOR does not inherently have envelopes, and this is actually something that we're going to propose as just the envelope basic capability, maybe not all the other things, which they don't like Bitcoin curves and all that, but the basic concept of the envelope, we might try to submit through the ITF. I don't know. But I think it addresses some of the things there. I mean, one of the big problems with all of this stuff is that the rest of the world is doing JSON, and it's really hard to be canonical with JSON. And I just saw somebody is going, oh, heck with DID key, we're just going to do DID JWK, and I'm like, oh no.
And one of the main design criteria of envelope from the very start was that it's not just a matter of being easy to be canonical, it's effortless to be canonical. If you, no matter what assertions you have, if you add the same assertions to the same subject, and no matter what order you add them in and so on, you get the exact same envelope out, and all its digests will match. And when you do the kind of Merkle tree preserving transformations like encryption or decryption of a subject, or elision, you basically get an equivalent structure out. So it has the exact same kind of Merkle tree that the previous one did. And so it's really more of a transformation of the same structure than it is a mutation of the structure.
And that is something that carry doesn't really do. I'm not saying it can't and that Caesar couldn't do it. I mean, I've even seen, sort of an attempt to try to do it with JSON in 2016. But doing redaction with hash trees and things of that nature is fundamental to this format. Elision, excuse me, because there's a difference between redaction and reference. Both are useful. Reference is, go look up the IPFS for this, or it exists someplace else. You've already seen it. I'm not going to repeat it. Whereas redaction is, you don't need this. You need my authority, my permission to be able to get it from me. Which is
elision is basically leaving something out, whereas redaction is basically deliberately withholding something, while referencing is basically putting something in place that lets you put it back if you're the receiver of something that's been elided. So it's really a semantic difference between redaction and referencing, but they're both forms of elision.
Yeah. But I believe it can be completely compatible with some of the schema stuff that both W3C is doing, and what Carry has some schemas as well. But those would be all within their own envelopes. But again, we don't have a partner sustaining sponsor in particular that really wants us to make that our highest priority right now. But I think all the other advantages, the ability to have multiple ways to decrypt and encrypt something, what we've called permits. I don't know if we're actually using that language. in the current
No,
DOS.
we're not using, that was an early idea I had for an encrypted thing which had various kinds of permits, but essentially we still have the same idea, is that, for example, an SSKR share is one way of encoding a symmetric key, a sealed envelope that's basically, or sealed message that's where you're basically sending something, a symmetrically encrypted message that where that key is then has then been encrypted using somebody's public key. That's another way of doing it. And you can have the same encrypted message that can have several different ways of decrypting it on it. And those are what Christopher's calling permits.
Yeah. Sort of related to that also is, we need to understand your requirements more. So I know a question came up with Bitmark. Since, we have this ability now to share into shares, shard verb into shares down, larger objects. I think they've elected to have to shard the entire relationship with autonomy, which might include multiple seeds, might include multiple different kinds of metadata, etc. Whereas proxy may be making a different decision, and they may be sharding completely separate, different parts of their system in different ways. So, understanding, how we envelope these different types of things and is, to meet your needs is part of what this tool will help us understand. Simon, any questions?
Just quickly, Wolf, on the docs that you showed on screen, is that available at a link?
That's, yeah. So that's
at the top of our repos. It just went up.
Blockchain Commons envelope -CLI -Swift. But let me show that for you again here.
Okay.
So yeah, so you can see the URL there at the top, Blockchain Commons envelope CLI Swift. The README file basically still needs plenty of fleshing out. It doesn't have a section on installation yet. You will need Xcode 14 or the beta, with they just released the release candidate today. But this is definitely coded using the Swift 5.7. But there are also some tools here. If you run the build and then link scripts in the shell, it should just do a command line build, and the link will basically link it into your user local. So you can basically run it from the command line. It's just lowercase envelope.
I'm hoping we'll do a brew binary version, in the near future, just so we have something that, people don't have to have Xcode to install. But it will be, at this point, we're testing it on Macs, so it'll be limited to Macs. There is Swift available on Linux and on Windows that theoretically can compile this. That's not one of our targets unless somebody really needs it. Again, this is a proof of architecture version, not a broad deployment library.
And by the way, if you are more interested, if you need to know more about envelope itself, then check out this repo, Blockchain Commons BC Swift Secure Components, in particular the docs directory. And this is basically where we have, this multi-chapter introduction to secure components and envelope in particular, and our Swift API from them, but also the CBOR encoding and all the details like that.
Yep, perfect. And to answer your other question, Chris, so right now, because we're potentially talking about recovering two separate devices or two separate things, as you mentioned, one being sort of the seed that's used to generate all the keys for your data vault, and the other one being the piece of wearable hardware, the ring. We don't want to tie them together, because the whole point of having a wearable is that it is a second factor, right? And if you can recover both through the same method, then you're back to it being one factor. It becomes useless multi-sig cosigner, for example, because it's no longer multi-sig. So right now we're treating them as basically being independently recoverable using similar approaches. So the same approach that we would use to recover your mobile vault, we would create a whole separate set of shares and configurations, but to recover the ring device, if you wanted to recover it. But one of the things where they do crossover is each one can be used as one of the shares to recover the other, right? So if you still have one of the devices, that gives you one share that you can use in combination with other things to recover the other device. But you still need.
Lose the phone, the ring can help you recover. If you lose the ring, the phone can help you recover.
That's right.
And if you lose both, you're going to go through more pain, but you can still recover.
Yeah, and if you lose both, right now the process is you recover your phone vault first, because you can do that through your vendor cloud storage and other things, and it's just easier to do that way. So you would recover your phone vault first, and then you would go back to whatever recovery you had set up for the ring and use the information, one of the shares you had in the vault, to assist that.
So Hank, there's one bit of context if you hadn't seen the prior videos. One of our goals is that when you have a brand new wallet, whether or not that's, you've got a proxy ring in your phone, or you've got the Autonomy app or Gordian or whatever, that you are instantly backed up in a no single point of failure or single point of collusion environment. So that is, part of the essential design. That being said, it's not, there are still some centralities in there that are weaknesses. And the goal is that as you have more funds, you use your wallet more, etc., now you can do a third share and either, you could still put that on Steel if you wanted to, or you can put it in a proxy customer could store it on Autonomy, and an Autonomy customer could store it at Blockchain Commons, and a Blockchain Commons person could store it on Bitmark. So, but that's sort of second to add more resilience and to prevent other kinds of attacks. And so that's kind of our immediate goals, is to support instant safety and then ability to become even more attack resistant and have greater resilience by taking advantage of these other techniques, social key recovery and some type of automated share recovery. So that's really kind of the ultimate goal, at least for the end of this quarter, is that we're using consistent formats, and we can begin to define, okay, how does when you're running the Autonomy app and you can go to the settings and it'll say, well, we're backing up your shard with Bitmark, and that potentially gives them some risk because Bitmark wrote this app. You do want to store that shard not at Bitmark, but with somebody else, and one of the choices might be proxy. And that's kind of what our immediate goal is, this year, or at least get to a good beta.
Yeah, that sounds great to me, because I know that that carry just simply stops at the beginning. It says you need to keep your keys safe. And that's it.
Yeah.
They take it from there. So I'm really interested in the forefront of that. And I think you guys are really doing a great job in that perspective. And I try to combine both, and that I'll focus on that. I'm just documenting for Carrie, by the way. I'm not a coder.
I have a question.
Yeah.
So in this kind of scenario, I have one case I want to ask a bit. So, for example, if I installed Autonomy and also Gordian Wallet, for example, but they all belongs to the same phone, right? So if I split my seed into multiple shards and save one in Atomy, save one in Golden Wallet, and maybe save one in Proxy. So if I just cannot recover my phone, does that mean I lost two of my shards? I mean, lost one Guardian and lost one.
Now, so Gordian, the Gordian app on your phone is sort of an equivalent of being able to put stuff on titanium or metal or whatever. We will, if we offer it, it'll be an online service, just like Bitmarks or proxies that you can authenticate with, and it will return you the shard. So it won't be, we're not going to offer that as a the default shard service. That being said, the formats are all compatible. So if you copy that UR and paste that or whatever into Gordian's seed tool, it's a standard format. And if you go get the other share, now you don't need Bitmark or Autonomy to restore your data. Seed tool can do it without the platform, without the app, without anything, if you wish to. But it's not intended as a storage location, a share location.
Yeah, so it solves the problem, like we breaking some important thing into multiple share and keep it in a different way. But what I'm worrying is about how can I get authorization to the Guardian service if I lost my phone? I mean, how can I do authentication? Is that by email?
I think the goal is that each service uses different approaches to authenticating. So a social service, Friends, has some instructions of, hey, Simon, I've lost my phone. I dropped it on the boat. I need your shard. I need a shard back. Can you send it to me? And we do this on FaceTime or Zoom or whatever. And he has some reasonable assurance in our back and forth in conversation that I am who we say we are. I now have an app on my phone, and I will give him, an opaque pair of byte words to send it back to me, and that also now authenticates him to me when he returns the shard back. But that's like one special case that is unique to that kind of social recovery. In the case of Bitmark, there are two authentications that happen. I think this is what we discussed yesterday, and this may not have been because of time zones. I think you guys just woke up, so I don't know if it's even been communicated. But the idea is that, like Proxy is doing something similar to this, there is a file that exists on the platform that gives one of two auths that you need to reconnect to the Bitmark service. So once you restore your phone, it has half of it, and then you do your regular email or SMS or whatever auth as your second auth to reconnect to Bitmark, and then you give them the shard. And that can be all relatively automatic. You don't have to have a whole lot of intervention and stuff. And that's unique to your particular use case. Proxy has a similar type of problem, but they have two things that have to be restored: the wallet and the ring, and which makes it a little bit more complicated. But I think we can handle all of these cases. There are some edges that are difficult. There's the one I call what were we calling it? It was the recalcitrant platform, but I had another word for it a little while ago, Simon. Uncooperative platform. So we have to make sure we cover the case of, you're an iPhone user and Apple now no longer does business with Russia, and you're a Russian customer, and you can't get not only can you not get the shard back from them, you can't get that little authentication hint that is necessary to reconnect to Bitmark. So that means that Bitmark needs to have another form of authentication that if they don't get, so this is in addition to the mail that they have now, that if they don't get the thing from the cloud service that is necessary, but they do get the mail, they may need to do one more kind of authentication. Maybe that's an SMS or some other kind of step. But it's the uncooperative platform that's a challenge. And it gets even worse kind of in some ways with Apple. I mean, what happens if Apple basically did the kill switch where they basically deleted every phone in Russia, which theoretically they could do? Then you also are missing the shard that is being stored on the devices, which in particular with Simon's story is, in theory, now you've lost the wallet and the ring. So you have 2 points of failure because of a platform. So we have to make sure that some of these edge cases we at least either know about or can address. I mean, I don't, the remote destruction of your device is the one that I don't have as easy answers for. I think it's doable, but I also think we may not want to do it because I think it may be too complex. It also depends who else joins us. So if, let's say Museum of Modern Art changes their mind and says, yeah, we'll do a shard that if you're a paying member of, the paying contributor patron of Museum of Modern Art, we'll store a shard for you. Well, we will store a share for you, excuse me. And what we'll do is, if you need your share back, you need to confirm that you still have access to the credit card you used before, or some yet another authentication technique. So the more parties that we have that have different reasons why they want to participate in sharing these types of things and have different authentication techniques for each of them that maybe don't depend on, Apple or Google or any of the platform vendors, then we're in much better shape should a platform vendor become nasty. But for that we need more partners, and we need to make it a priority that it's a threat that we have to solve before other things we want to solve. I mean, personally, I want to get the what Carrie calls a SCID. I want to get a very simple version of that working in the envelope architecture, the Gordian architecture, because I think that both proxy and Bitmark are going to want to do the thing where it's roughly the signal equivalent. So right now, proxy intermediates between the if they're going to do a social network thing, which won't be in their first version, I don't believe. Actually, the better example is Bitmark. So Bitmark did an app last year that didn't come out that had social key recovery, but you had to basically communicate with the other party through the Bitmark app. Okay. And they basically used a version of the Signal protocol to do that, but it was pretty much unique to Bitmark. So it was facilitated to Bitmark. So in theory, Bitmark could do a denial of service to that facilitated connection. I think we're all going to want to be able to have a secure connection to our social networks that is, independent of any one vendor, and having some kind of simple SCID that, is DID-like would address that. So my gut feel that's more important than, an explicit attack from, Apple or Google. But,
Yeah, one of the way I've been thinking about it is instead of trying to set up like a single set of recovery shares or a sort of a single recovery configuration, there isn't anything that's stopping you from creating multiple.
Yeah.
Right. So you could just independently sharded sets. So you could make one that uses some subset of vendors and providers and devices or whatever. You could create another one that uses a different subset, just sort of to give you more robustness. If you're, this is more of a obviously more of an advanced use case, but I kind of see this as in some, like in your app or wherever you shouldn't be limited to, like, this is the one true way to recover your thing. Here's a way to register multiple recovery options, just as you can register multiple options to recover your Google account. You have multiple ways that you can create to recover your keys.
Yeah. Also, there was some interesting things that we discovered when we were doing some work with Bitmark last year. There's opportunities to pre-share some sets that aren't valid to start off with, but you send them to the parties you're already committed to. So let's say if it's a 2 of 3, you go ahead and give them part of a 4 of 9. So now 3 of your 4 of 9 are ready. You don't have to resend them. You don't have to set up any new relationship. You just need one more, and boom, your 4 of 9 is now a backup capability for restoration. And you've got 5 more, things to make it more and more reliable. Or if it's a 2 of 3 of 2 of 3s, which is, one of my favorites, same thing. But you can pre-share those because they're really useless until there's a quorum of them distributed. So
yeah, we're actually we're stealing that technique, and we're using that for the share that you would store on your Ring device. We're generating that ahead of time because the expected entry point is through the app, and then you purchase the hardware device later on, or it gets delivered later on. But we're pre-generating that group and that share, and just storing it in your vault and not using it until you register a Ring device, and then we already have that ready, so we don't have to recreate the entire set of groups when you do
there's
that.
definitely some things, we haven't talked about post recovery. So let's suppose, we've now recovered. At what point do we need to do rotation? What are the rules when you think that it wasn't just a loss, but it was an actual compromise? Things of that nature. So, you don't want to have to go through all the different steps you did to do a post recovery, whatever we're going to call that term, but we need to design that as well. And some things you may decide, hey, it's too much trouble to move my Christopher A.eth to a new Ethereum address. And so I'm just not going to do that. I'm not going to rotate it because it's too hard. Or something of that nature. And we need to deal with those weird edge cases.
Yeah, another one somewhat related to the post recovery, but testing sort of ensuring that whatever recovery mechanism you set up is still okay and is still valid. Like any backup or any recovery mechanism is only as good as the last time you've used it. And I know with
PSS.
Shamir security, you can't actually do it without collecting the shares, but at the very least, you can query all the different parties that you've given the shares to, and you don't have to ask for them back, but you can just say, like, non-cryptographically confirm to me that you're still around, you still have it, at least until we switch to something like VSS, where it can actually be done cryptographically as well. But that's something that we should think about building in as well, is how would I periodically ping whatever services I've distributed my shares to, or people I've distributed my shares to, and just say, hey, just tell me you still have it.
Yeah.
And if some of those become unreachable for whatever reason, give the user some indication, hey, you've set up a 2 of 3 split, and one of your three hasn't been reachable for 2 weeks, you're now at risk potentially of one more failure. So maybe you want to reconsider or recreate it.
Yep. I also like what we saw in an earlier demo from Bitmark, where they actually had, I don't know if they're going to make it available to customers, but it was, hiding in the settings, where you could actually test all of the failure modes. Like it would simulate loss of platform and a new phone. It would simulate, reconnecting with Bitmark. It would simulate. Well, it's not really simulate. It's actually doing it. It's basically forcing all three big failure modes to happen. And that, is a great way, when the customer comes along and says, well, prove to me, you say, well, prove it to yourself. Go to settings under the emergency thing. Here is, give it a try. So I liked that. I think that's a potential UX pattern. Security UX pattern.
Christopher, I have a question too. You were mentioning Ethereum addresses in relationship to rotation. Could you explain that a bit further?
Sure. So a number of different assets in Ethereum are more challenging to rotate to a new key than, say, Bitcoin is, because they're part of a smart contract, or for instance, if you've got a key that is used as part of a multi-sig smart contract, I don't have no idea how you rotate that. So if the smart contract, say a Gnosis smart contract, owns your NFTs and your, I don't know how to rotate that. It's a much more complex operation in the Ethereum community, because they don't have real multisig. It's not, there is a cost for doing it on Bitcoin, but because it's not it's UTXO based, it's pretty straightforward. You just forward it to the next UTXO on a new key, and no big deal. You paid a small transaction fee for it.
Exactly, that's a transaction. It's not a rotation.
Correct. Well, it is a rotation. You're going to a new key, but and basically saying,
All
I'm
right,
not
yeah,
going to
so
anymore. Right.
Then we should agree on the definition of a pre-rotation and a rotation.
Yeah.
Because it's a transaction on as soon as at least I was in the conviction that you can't rotate when it's as soon as the value is hooked to a blockchain. You have to try that.
Yeah, BTCR does rotation. You can basically, with the original BTCR, you point to a UTXO that has value on it, and the action of the parties that can spend that UTXO determines what the new key is, but you don't know what that new key is until the party spends that, and that particular key can be not at all related to your DID key. It is purely a rotation key, and one of my favorite versions of that is you just do a 2 of 3 multi-sig and give that to your friends and say, pay yourselves $100 if I misbehave as a bounty, and rotate my key for me if I if you're seeing spam happen on this particular address, and obviously give it to people that aren't going to just arbitrarily want to steal that $100 from you, but you can do that, and that's absolutely a valid way of doing a rotation. So
all right, thanks for the explanation.
It also becomes a lot easier once we have Musig and Frost. There's a lot of cool things we can do with that on Bitcoin that I don't know how to do with a smart contract on Ethereum. We just don't know how to do it. So, but I can do it on Taproot. On, any questions from you?
Yeah, I have a question. So our case is to put multiple seeds into the crypto envelope. So do we need to convert into the form of UR crypto seed before putting them into the envelope? What would you
So
recommend here?
yeah, so envelope itself is not, UR is a layer on top of envelope. So even though the command line tool inputs and outputs UR, it basically parses that into the actual envelope data structure, which is a data structure in memory, and which basically, any part of it can be represented in any way. The primary way that internally it wants to represent any structure you give it is CBOR. So, like for example, if you hand it a subject, anything that is, for example, in Swift, I have a protocol called CBOR encodable, and anything that conforms to that protocol can be handed to envelope as a subject, and therefore it stores the actual CBOR encoding of that. Now, so you can CBOR encode an envelope itself, including all its assertions and all that, and just transmit that over the wire. It's just a CBOR structure.
Let me explain
The whole point of UR is to basically have something that's copy and pasteable easily, or transmissible in QR codes or other things like that. It's a handy input output format. Then it's kind of URI, but underneath that, it's just straight binary.
Right. So to maybe describe it a different way is that the CBOR, pure CBOR encoding of a crypto seed is just basically a tag in the 16 or 32 bytes.
Yeah.
And
it's a CBOR map.
And you're not going to be sharding only that seed, and you're not going to use that seed as the value you're going to shard. It's just going to be just like any other metadata about your accounts. It's going to be thrown in the big bag of all the stuff about that user, 3 or 4 crypto seeds that are wrapped with some identifier that says this is account 1, this is account 2, account 3, or whatever. And then that whole thing is sharded. And that is sharded not with a seed. It is sharded with a key that was only unique for that session, which is why we need to I think we may have some in our examples. Wolf used the word private key in a couple of cases where really it was a secret. I mean, we need to be clear on that. They're exactly the same in some ways.
Yeah.
But we need to be clear that it's an ephemeral, like you're only using it for a single session for that single sharding that you're doing, because it's only recovered when you have the thresholds. It's not a seed. It's only for that particular session.
In all those cases, I call that a content key. So basically when you're either, when you're basically encrypting a symmetric key, you're basically that symmetric key, which is only ever generated and used once for that one session, is the content key. So for like SSKR, you basically, you still need to split up like this 32 byte secret. Well, what is that 32 byte secret? It's the content key. So you symmetrically encrypt the subject of the envelope, and then, and with that content key, and then you split the content key into several pieces and you add that as an assertion to each one of the shares. And so once you get enough shares together, you recover the content key, then you decrypt the actual envelope.
Yeah. The main advantage, I mean, honestly, the pure CBOR SSKR, where you were splitting up the seeds, so crypto-seed, the version of that, which is we've had around for a couple years now, really is only for those situations where you don't want anything else, and that the result is very small. So say in byte words, if you exclude the standard word as words at the beginning, it'll fit on a 25-word plate if you want to stamp it. Whereas these things, because we're doing cha-cha poly and other different stuff, they're not going to fit on your titanium plate like the raw CBOR of a crypto seed under SSKR.
But just the binary format could very easily fit in, in Internet Protocol packet, you know, that doesn't need to be UR encoded or anything like that. The real advantage of a UR from a human perspective is, you know what you're being handed. It is a uniform resource. It has a type, and then it has a bunch of byte words. And then, but you know at that point what to do. You then convert it to, you know, CBOR basically, and then you look at the structure of the CBOR. If you know the type, then you know you can go reference the schema that it's supposed to be for. Like if it's a UR crypto seed, you can go look at what the spec is, and you look up what a crypto seed is, what its fields are, and so on. And then you parse it. So it's not a self-describing schema, but it is at least self-identifying in terms of its type.
Yeah.
And of course, if we want to add schema languages later, we can.
Yeah.
So any advantages or any standard later on that if for example our specific case where we want to put multiple C to the envelope and let all the apps to read through the envelope after recombining to extract the C, does you recommend us to push into the UR format right now?
Yeah,
It really depends on what you want to do with it.
My basic thing, anything that is persistent that needs to be restored in your current set of decisions. So that would be obviously, you know, the autonomy seed, maybe the Ethereum and the Tezos seed if they're different. You know, any watch only seeds, obviously those are the easy ones. But also things like if you ever do Bitcoin, a descriptor, you might want to throw in some of the asset information. Like here is you know, here is a list of the IPFS references to the assets that people have or whatever. All that metadata that Bitmark might help a user have, but if Bitmark goes out of business and they want to now use some other app for it, that should all be available, you know, in that share. I don't see. I mean, I wouldn't put like the you know a gigabyte image in the share. Yeah, I would put a reference to the gigabyte image,
Right.
but that's what Elysian's good for.
Yeah, so this example that I have here, this is part of the documentation on the secure components. You know, shows an example of a verifiable credential. It has an ID. This is our common identifier. It's just a 32 bytes, and then it has these other assertions that have been put on it by the issuer, including, for example, this is just a string, but it represents a photo. And there's no reason why you can't put a whole photo in there. It's just, you know, CBOR, could be a CBOR of a JPEG, or you could elide it or just put a reference basically. So it's a digest that if you retrieve it, you know you have the right digest because the digest matches. Any one bit different, it won't. And then you have custom non-registered predicates here, and then you have these registered predicates, which are basically called well-known predicates, which are tinier. They're just like 1 or 2 bytes, whereas these are a string. And so you can see how you can build this up to do anything you want. If you have several seeds you want to store for different things, this could be, you know, your user identifier here, and then the assertions on it are, you know, who created this seed, you know, the manufacturer or whatever, and then the seed. And then if you want to, you know, you can sign it, you know, as a total structure. So you make sure that when you get it back, it hasn't been altered, because you can verify the signature, you know, it hasn't been altered. So again, you mix and match. You can make these structures arbitrarily large. I mean, because every one of these things here, this string is really an envelope, so it can have its own assertions on it, and so on and so on.
And if there's something that's sensitive, you can put envelopes inside envelopes. So I know that, you know, Simon, they also have a file that they're storing in iCloud, and some of it is readable. I think you're just doing JSON right now. I mean, you know, I don't know if you'll be switching over to UR.
Yeah, that's correct. And that's, yeah, right now it's a JSON file, but we would be looking to switching that over to be an envelope, so we can yeah, because right now we're doing SSKR for the seed itself, and then putting that SSKR share in this recovery config file, I guess, that we're storing in various places. But yeah, we would be looking to replace that whole file with an envelope file that contains all the information, including the seed.
Yeah. And so that, there may be scenarios like the non-cooperative platform scenario where they want to put some hints as to, your social network or other different types of things in the shards that are given to your other social network partners, or maybe not. I mean, I think it's, that can be its own threat, what we call a roll-up attack. But we can help you analyze, these different envelopes inside envelopes if any of those types of threats become an issue.
I have a question. Like, currently the envelope CLI only provides symmetric encryption and decryption. So does that mean if we want to exchange shard or any messages, we have to set up a process to exchange the key, the shared key first?
So it actually provides both public key encryption as well as symmetric encryption, and you can mix and match those. So I'm not sure I understand the question.
It also does Diffie-Hellman. So it's just we just didn't describe all of that. It's not fully in there yet, but the intent is that it'll do
the envelope data type already does it. The envelope command line tool still need to add that capability. But the idea of using a sealed message is that you have the public key base and the private key base, and together you basically make a Diffie-Hellman agreement, so you get a symmetric key, so you can then exchange secret messages, and it's all baked into how envelope works.
Right.
Yeah, it's basically an integrated encryption scheme, right? It's very similar to the standard integrated encryption scheme. So the data is encrypted with a symmetric key, but that symmetric key itself is ephemeral, and that can be a result of a Diffie-Hellman or SSKR split or
exactly.
So building this kind of envelope technology normally using symmetric encryption, is that the common sense of this area? Or
well, if I understand the question, I mean, symmetric key encryption is one of the building blocks of everything else we're doing.
Yeah.
But built on top of that, we're using key agreement with basically public and private keys and so on, and as well as signatures with public and private keys, and and that's what rather than generating a public key or a private key, you generate a private key base from which all the kinds of private keys can be derived, and then the public key base can produce both a signing public key as well as an encryption public key. So you don't need to decide whether you're just doing signing or just encryption and messing with different keys. They're all available to you when you use this kind of integrated, the secure components in envelope.
I mean, most people don't. I mean, if you think about it, there's no reason why you couldn't do public key encryption on a large amount of data, but you're going to spend a week encrypting. You only encrypt the hash, so you're already using tricks with symmetric encryption, no matter what modern thing you do. So we are trying to build at the very bottom a strong foundation before we go up. I mean, I've got all kinds of ideas. Like I want to be able to have keys that are capability keys. Bitmark was very interested in authorization tokens and things of that nature last year, and the year before, and those are yet another kind of key and a framework. And we've tried to design the flexibility of the Gordian architecture and envelopes to support those things, but we're not choosing to define them right now because I think we're at least reasonably confident that there's room for it there. We've thought about it; it's possible. Similar with like schemas. So right now, if you want to do JSON LD, you have to understand how schema works, or you have to have a library that understands how all their schemas work and how to do RDF canonicalization or trust a library to do all that. Well, there's no reason why you can't do RDF canonicalization and reification, all those complex things, I believe, we'll know more as we have architectural review, believe you can do it. It's just not required. Sometimes just Alice knows Bob is sufficient. We don't need a complex schema for a lot of these different types of things. So we're trying to take that kind of design approach to all the different aspects of that we're doing, which is let's not overly too early design some of these things. Let's just be confident that our architecture can handle it. So if you've got something we don't know about, we haven't talked about, that you think that's an important future, you know, let us know soon so we can basically add it to our list of, is that theoretically possible with our architecture?
Some of the most fruitful conversations Christopher and I have had was where, you know, I'd propose a structure, like there was a very early kind of proto envelope structure I did, and he said, well, how would you do this or that with it? And I'm like, I'm not sure you can do that, which is why I ended up designing what is presently on the envelope structure. And since then, we've had a number of conversations where he said, well, I wonder how you would do like remote procedure calls and so on. So I went away and said, okay, here's how a proposal for how you do remote procedure calls. And we have that working right now between Seed Tool and Gordian Coordinator, which is what I'm also working on, where they can exchange QR codes with basically one doing a remote procedure call to the other through QR codes using envelope. And so the kinds of questions I would love to get from the community is, you know, okay, envelope's cool. How would you do this with it? And let me think about it and come back and say, oh yeah, okay, this would be either trivial, or we could expand it this way, or you know, if it's something that only you need but the community doesn't, then here's how you define it for yourself. But you know, I'm trying to create basically the Lego bricks out of which we can build a whole new generation of smart documents.
Yeah, and the thing that I find exciting about the structure is so we are right now as part of the proxy product, one of the things we do is we exchange and allow querying of verifiable credentials, and we encapsulate various other documents in those. But the sort of the elision properties that you keep on bringing up, the existing structure in VCs and also in things like the ISO 18013.5 mobile driver's license standards and things like that depend on the issuer enabling selective disclosure when they issue the document. As a user, I can't make a choice. And like I was excited about the ISO driving license stuff that Apple was pushing until I saw that as soon as they announced it, the American Automotive Association, whatever, published this guideline that basically said, okay, well, in order for this to qualify as a driver's license, it must include these fields, right? And you no longer have selective disclosure because no issuer is going to generate separate signatures for the individual fields. Whereas this structure specifically allows you to either redact or elide information without the issuer having a say in that, right? You can just choose to replace it with a digest and the document still works.
Exactly, and the signature still verifies.
Yep.
Yeah, so that's,
you can't actually change anything, but you can elide it. You can even encrypt parts of it.
Yeah.
And without invalidating signatures, because it's basically a Merkle tree with certain kinds of Merkle preserving transformations.
Yeah. And that is at the heart why I'm diverting from, you know, some of the W3C stuff that I've been very deeply involved in the last 5 years, is that, you know, there just wasn't sufficient requirements there. And maybe this will be VC 3.0. I don't know. I think it's possible.
Yeah, well, I think for us, like the future, you know, right now we have a product that uses VCs and a lot of that infrastructure, but I easily see us replacing that with an envelope structure in the future, because it's part of our internal kind of request mechanism anyway. It's not necessarily something that we can rewrap all the things we already have, right? And transforming it into something that gives more of that user control for which information is actually shared. I easily see adopting that in the future just for that reason.
Right. So we need to call it. It's been an hour and a half, and I know some people have some hard deadlines. So thank you very much for participating. The big question is, do we want to meet in 1 week or 2 weeks?
1 week's the Silicon Salon.
Oh, right. So how about 2 weeks for our next call? Does that make sense for everybody?
Yeah.
Okay.
Yeah, that makes sense, man. Do we have is that like, I think the envelope stuff is looking pretty good with the CLI and everything to be able to test it out.
We're
Do we
hoping to
want
have
to
some more
define like
info in demo.
some goals which are recovery specific? Like there's a whole bunch of things that we keep on talking around in circles, but we should probably start kind of define, if we want this to be interoperable between different services, we should just start defining what those formats look like, what those structures look like, in terms of actually getting to something interoperable by end of year, maybe.
Well, one of the key ones is crypto request for an SSKR shard. And do we do the authentication inside it or outside it or support? I don't know. So we can
Yeah,
talk.
yeah,
about
and
that.
also how do we potentially reconcile the different ways that different services may authenticate?
So for my part, the most important thing for me would be, user stories that involves, say, swim lane diagrams with different agents passing messages back and forth, requests and responses, and then that would help me kind of conceptualize how to create specifications that leverage envelope that can do all that.